We've got the clicker to advance with, Jim. If there's something that you need done on the computer, you can holler at me. And
That'll be fine.
No way.
Just gonna jump in there. Bear with me for a second. I'm just gonna load these so we don't have to watch ads now that every time there's a video, there's an ad. There we go. Okay, just one more thing to pass out. Actually, if you want to just put a stack on our own speech, that would be awesome. Just like just a bunch. You can just do a pretty big stack. Just like.
I'm impressed you have that many pairs of scissors.
I know, I do really like crafts, so I've found quite a few throughout the house. This is for you. You're welcome. Okay. This is for you. And everyone has all the handouts. Thank you, Austin, appreciate it. And clicker is up there, or
Hopefully you get that.
Yeah, hopefully it's not ducked in the parcel. Pocket.
It is, I'm gonna have to hunt it down.
here.
There it is right here.
Oh, perfect. Here it is.
You are good to go.
Thank you. Thank you. All right. Okay, so you guys are lovely middle school students in a science class, and we've been talking about weather and different climates, and so we're gonna continue our unit on that. So hello everyone, how are you guys doing this afternoon?
Good.
Good, awesome. Well, today we're going to continue our discussion about climate and different weather patterns. So if you recall from last week, we were talking about tropical storms and hurricanes. And we've all had discussions of being here in Florida, how that has impacted some of us personally and some of our families recently with Hurricane Hermine and Matthew. Today, I know it's Florida and it's not very cold outside, but we're going to talk a little bit about snowflakes. So has anyone ever been in the snow? Anyone? Anna, also, actually a lot of us. Great. Has anyone ever not seen snow? BJ, you've never seen snow?
Yeah.
Okay. Well, we're going to learn a little bit about snowflakes today. Has anyone heard of the expression, "you are a special and unique snowflake"? Does anyone know where that comes from? What that means? Yeah.
Maybe every snowflake is different.
Yeah, so scientists tell us that every snowflake is completely unique. And so today we're going to talk a little bit about why that is and the science behind what creates snowflakes and why each one is said to be unique or whether or not that's actually true. So we're going to explore that question today. So if you all would look on your desk, you've got a couple of handouts. If you look at the one that says snowflakes at the very top. So to begin our activity, I would like you to reflect on, write down, and I apologize that my screen got a little bit messed up, but write down everything you know about snowflakes or snow in general. So think about the discussions we've had about weather and about how the discussions we've had previously about water and molecules, and just write down everything you know about snowflake formation. So it can take a minute or two to do that. And then if you also answer the second question, so after you write down your thoughts, if you answer the question, do you think it's true that no two snowflakes are alike? And then write down why you think that either is true or isn't true. Awesome. So if you're writing, keep thinking, but we're gonna move on a little bit. So today we're gonna answer two essential questions. So we're gonna look at how snowflakes are formed. So we're gonna look at the science behind how water crystals or ice crystals are made, and then we're also gonna look at the question because there's some debate about whether or not every snowflake is unique. So we're gonna look at that. So for our learning objectives, we're gonna look at how ice crystals are formed, and then also we're gonna get a chance to practice forming hypotheses and looking at data and then reassessing our hypothesis based on some of our observations and the things that we learned. I'm going to show a quick video to everyone that they've figured out a way to film snowflakes and how they're formed. So I'm going to allow you guys to all watch that process, and so you're going to see the formation of snowflakes, and so make some observations about that process. And then within your table, I would like you to come up with a hypothesis. Can anyone remind me, what is a hypothesis?
Hunch.
Yeah. You know what were you going to say?
Educated guess.
Yes, exactly. So a hunch or an educated guess or a prediction about why you think something is true or not true. And so you're going to form a hypothesis as a table about how you think snowflakes are formed based on this video. So that's the first part of the worksheet. So you're going to answer what causes snowflakes to have different shapes, and you're going to create a hypothesis about that part. So let's go ahead and start the video. Is there any way to get, oh, here we go. Just make this sound a little louder. Awesome. So if you notice from the video, there's all different types of shapes that snowflakes come in. So I would like you, within your small groups, within your tables, take a minute or two and form a hypothesis about what you think causes snowflakes to have different shapes, and jot that down. So develop a hypothesis about why you think, or what affects the different shapes for snowflakes. So I'll give you guys like a minute or two to think through that.
Factors do the best, right? Or the surface tension as it changes from liquid to solid.
Immediate condensation.
The rate of it, the rate of condensation.
Also the distribution of dust particles.
Okay, so
It's snowing.
I was thinking the temperature and the atmospheric pressure might impact it.
Just can be tan temperature, steep.
so we'll say yes. I heard that before too. I don't know. I thought it had something to do
Maybe the speed at which
crystal data
it
structure.
forms, which is probably impacted by a lot of degree.
But then I don't know if it's like everything's perfectly symmetrical. I don't know how to so just. Conditions. Change structure.
I guess that was like where about the atmosphere and how far it falls and stuff. I don't know. I'm sure
I
that.
thought that's what you mean by
Pressure. Yeah, I'm sure the pressure's different, but thinking about how it falls and
I
how
don't know
it
if they
goes
come
through,
together.
like it might go through different zones.
But I seem to recall that I get these little video.
So I think the height would
Yeah.
impact temperature and pressure.
So you're saying the changes that it goes through, different
Yeah.
altitudes?
So I'm going to give you guys about one more minute. So after you've had a discussion, go ahead and write down your hypothesis.
Our hypothesis should be that all of these factors could impact.
No, I agree.
Yeah.
I should just be a weather forecaster.
All the factors might result in different shapes of snowflakes.
All right, so let's go ahead and hear from the different groups. If I could hear from this table up here, what did you guys write down for your hypothesis?
I'm gonna let Bree handle this.
A weather forecaster?
No, it's just a complete guess. It really is. So I feel like the amount of humidity in the air really depends on what type of formation you're gonna have, because it's the amount of liquid present, and also the temperature. And then I thought too, the temperature is related to, I would think, surface tension that has to do with water and solids. So if the temperature was just very cold and it was turning directly into a solid, or a lot quicker than, I guess, a slower transition into a snowflake, then you'd probably have a different formation.
Awesome. So humidity and surface tension impact the shape of, and temperature impact the shape of a snowflake. Awesome, nice job, guys. What about you guys?
We had a similar, so we said temperature and humidity, and it changes that crystal lattice structure when they form.
Awesome, nice job. And our table in the back?
We said that the shape can be impacted by a variety of factors, including the rate of condensation, the dust particles and smoke, the temperature, the atmospheric pressure, the speed that it forms, the altitude, and the changes it experiences as it's falling.
Awesome, so you've got the whole list. So things to do with the weather, also how the snowflake falls, and different weather patterns and temperature and all of those things. Those are great predictions, and a lot of them align with some of the things that we've learned about weather in the past. So the next thing that we're going to do is I want you to actually get the opportunity to create a snowflake so we can think about the different shapes. So on your desk you have coffee filters and you have a little half sheet of paper with instructions on how to make these. We're going to do this pretty quickly, so I'm going to give you about the next 8 minutes or so to go ahead and make snowflakes. And so I want you to do 2 things for me. The first is, and this is all outlined on your instruction sheet, is I want you to actually create a snowflake yourself. And so it's a pretty simple process. You're gonna fold, actually Pete, can I have one of this?
I'm working on it. There you go.
Thank you. So just to help you, to demonstrate a little bit, so you're gonna take your coffee filter, you're gonna fold it in half like this, you're gonna fold it in half again. So you've got like a little triangle here, and then you're gonna fold it in half once more. So you'll end up with a triangle about the shape. You don't necessarily have to do it this way, but this makes it easy to cut. And then you're gonna cut some different designs into your snowflake. And so I've got some examples on your table, and you will come up with something that looks like this. Now, they will all have different shapes based on the little designs that you cut into them. So if you work pretty quickly to design at least one, if not two, and you'll have to share the scissors. So go ahead and create a snowflake. Anyone have any questions?
Thank you.
Sorry, did I?
No, I messed up.
Oh, no, you're good. I'm not. It's fine. It's fine. It'll just look like
Nice.
yeah, like the age, like the tea leaf. Yeah, I'm not worried
Sorry
about
about
it.
that, I walked ahead, I just knocked it over.
Oh, no worries. I'm not worried about it.
Uh-huh.
So make sure everyone creates at least one, and then if you're done with yours, go ahead and make one more. Those are the specialty scissors. They're a little bit harder to work with, but yeah, they do cut. They just make different designs. So it'll end up looking like this.
Yeah.
Yeah. Yeah.
Then go one more, right?
Yep. And then make sure you have some pretty good folds on there, and then cut right along your edges to get your different shapes. And just make sure you don't cut too much this way, because that'll cause your snowflake to fall apart. Nice job. Fun. All right, I'm gonna give you guys about 1 more minute to work on your own design. So finish up your snowflake. Nice job. Oh, you're doing like a hole punch, that's nice.
The whole thing is fun. I think.
Yeah. I'll have longer and intricate over there. You should, Louise. You freaking want to hold up your snowflake?
Very pretty.
Lovely.
Okay,
Can you hold yourself, please? Oh, it's lovely as well.
Doubles as a mask.
All right, so hopefully everyone has gotten to create one or is just about done with theirs. So if you will now take your snowflake and if you will hand it to the person on your left. So go ahead and take your snowflake, or within your table. We'll just make it within your table to make it a little easier. So hand it to the person on your left. Awesome. And then, yeah, as soon as you guys are done, if you'll trade. And then what I want you to do next is I want you to look at that snowflake, and I want you to take another coffee filter, and I want you to see if you can recreate that exact design.
Good luck.
So take a look there, look at the different shapes, and see if you're able to replicate that exact snowflake.
Oh man, great. Good luck, Austin. You got a lot of work to do.
They make fun of me, but I don't know how to pull the thing.
All right, and work kind of quickly. I'll give you guys about the next like 3 or 4 minutes to work on that part.
There it goes.
Oh, yeah, it is.
Oh, I remember those.
Nice.
Maybe these are right hands.
But it is.
I did that earlier. Oh, it's okay. I did that earlier today.
It's a special snowflake.
It is. I think it's the same pattern. Okay, some snowflakes melt before they make it all the way down to the ground.
Yeah, that's when the snow gets.
All right, I'm gonna give you guys about another minute or so to finish your partner's design.
Pretty close, not quite.
Yeah.
Get to
Ooh, it
me,
has some
guys.
face to it. Yours has a pretty face. That's one me. That was intentional. Yeah.
All right, so most of you are finishing up. So the next thing I want you to do is, once you've finished your snowflake, I want you to compare the snowflake that you created with your partner's snowflake. So hold them next to each other and see how close that they look, and decide whether or not they are really close or exactly the same. And then once you've compared the two designs as a table, I'd like you to answer questions 1 through 3 on your worksheet.
I did it with my right hand, so I don't really know what that's about
I think if I was
Yeah, that's
attached,
I think it'd be good.
it kind of looks like it. But it's not. Close.
If you guys discuss questions 1 through 3 as a table, I'll just jot down a couple of your responses.
Okay, Mika, ready to see? Did I have my replica?
I'm sure you did it.
Yeah, pretty close.
Sorry.
But not yours.
So then
This
this
is
is
hard to replicate with the shears.
A lot of full punches.
right. You're close.
These were pretty easy. The parts that were hard were like these parts, because with the pinking shears, trying to get.
They're a little bit harder to come away from. So as a table, if you guys will discuss questions 1 through 3, and then jot down a couple of your responses.
Right, here's the base.
Well, the way that the weights are positioned
They kind of
makes it easier for their eyes.
What's happening?
It was a mess.
Yay! Good job, BJ.
You got a very intricate one.
It's nice. Nice geometric.
Yeah, I think you did lots.
So then make sure you guys get a chance to answer the
Yeah.
questions. All right, so we give you guys about 2 more minutes to finish on your thoughts about the first 3 questions.
Really close.
And the temperature actually cools.
Super close.
And reach them.
Close, but not exactly. Yeah, the purple marker. I'm not gonna understand. Oh, it's on the floor there. That blue and gold? Okay, yeah, that's that. You're welcome.
Hold on. Sure, so. Sure, so.
Oh, you want it? Okay. Yeah. Good thinking, Blake. Always leading.
Yeah.
So you guys get a chance to get through all the questions? Just the last one? All right, so let's hear from the different groups. So this group up here, if you guys want to answer for me the second question, so what factors went into creating the snowflake and the unique designs of your partner?
Like making sure, like she had fun edges, so I had to make sure I had fun edges.
Yep, absolutely.
I don't know if that's like technical. I think the strategic placement of the larger circles right here, that was the key to making it similar.
She was better at cutting than I was.
Well, yep, and also depending on, some of the scissors are a little bit easier to work with than others. So the placement of the cuts and also the shape. What about you guys? What factors went into the different? Yeah. Sounds like yeah, you got a pretty intricate one. You want to show,
Yeah, look at this.
show the class?
This is like advanced snowflake man.
Wow.
I'm novice.
Yeah, that was a lot going on.
Did you give a lot?
Just a little bit.
Close.
Yeah, you got the basic shape for part of it
Yeah,
there.
just some basic shapes.
And what about you guys? At your table of doom, what factors do you think went into the different designs?
They were close, but not exactly the same, and we attribute that to the type of cuts, the placement of those cuts, and use of face and flake being different.
So
Also, these pinking shears make it really hard to replicate cuts. Like if it's not used just straight, like if you're doing little cuts, it's really hard.
yeah, those are a little bit harder to work with. They, for those of you who haven't used those scissors before, there's a little design in the blades, but they're a little bit more difficult to work with. Awesome. All right, so what we're going to do now is we're going to watch two very short videos about the science behind snowflake formation. So as we're watching these, if you would jot down some notes, so pay attention to what elements actually impact the snowflake shape. So jot that down on your worksheet. There's some space there for you in question 4. So make some observations as we're watching these two short clips.
But it's not just water in motion that shows invisible beauty. When temperatures drop and water goes from being a liquid to a solid, it takes on dazzling forms. If there's one person who can open the doors to this invisible world, it's physicist Ken Lebrecht, the snowflake fanatic. Lebrecht is an art collector, but what he collects are the works of nature, like these delicate ice crystals. Under his microscope, their amazing designs are revealed.
The snowflake is a really complex structure which appears out of nowhere. It starts with water vapor and ends up with a very elaborate shape. And it sort of cries out to be explained as to why exactly it has that shape. You'd be surprised at how little we really understand about how crystals grow, and snow crystals included.
To unlock the hidden mysteries of snowflakes, Lebrecht takes his camera right to the source.
I've been up to Alaska and Michigan and Vermont and Ontario and Sweden and Japan looking at snowflakes. Different locations produce different kinds of snowflakes, mainly because different locations have different climates.
Having studied snowflakes all over the world, Lebrecht is truly the man to answer the age-old question, are any two snowflakes the same? He says no.
The reason no two snowflakes are exactly alike is just that they're complicated. And the number of possible ways to make a snowflake is very close to infinite.
He delicately mounts the crystal, some less than a millimeter wide, on a glass slide. Then he photographs them through a microscope lens.
And each snowfall brings a different mix of crystals. It's really a lot of fun, I mean, to go out snowflake watching.
These thousands of snowflake photos are a great example of the endless diversity that nature produces. But back in his lab at Caltech, Lebrecht also builds his own designer snowflakes.
In terms of understanding the science, we like to grow our own snowflakes in the lab where we can control everything.
He simulates the conditions found in clouds thousands of meters above the Earth, where the tiny flakes form out of water vapor.
So what we have here is a machine for making snow crystals. You can think of it as like a big snow globe, except it's not clear, so we can't see inside, but we can look at the crystals as they fall to the bottom.
By adjusting the air temperature and humidity, he creates the extraordinary, a man-made snowflake, complete with its own signature design. Each new snowflake is a chance to learn more, from classic holiday stars to strange columns and needles. He estimates he's created millions of these faux flakes, and he'll create millions more. But he doubts he'll ever see two shapes exactly the same.
The number of possible ways of making a crystal is very, very large. It's bigger than all the molecules and all the stars and all the galaxies and all the universe. Okay, so it's a big number.
Which means that we get to see an endless variety.
When you look at one snowflake individually, it's really a little microcosm all unto itself. It's really kind of an interesting little mystery going on. It just falls out of the sky.
All right, so in the interest of time, I had one other clip to show you, but we'll look at that tomorrow. So what did you guys learn from this video? So what are some of the things that impact the shape of snowflakes?
Climate and humidity.
Yep. Climate and humidity, what else?
The amount of snowfall.
Yes. Other thoughts?
He said there were infinite ways that they could form to form their design.
Yes, and so actually there's a little bit of debate. Scientists disagree slightly about whether or not two snowflakes could be exactly alike. So we learned that there's differences in temperature and humidity impact the shape of the snowflake. Also, like if you look at, we've learned about previously how water molecules form with your hydrogen and your oxygen molecules, and how when water freezes, it has the six sides of the snowflake shape. So depending on the temperature and how the snowflake falls, it'll make different shapes. So if it's a little bit warmer outside, it tends to have like the longer needles. If it's a little bit colder, they're more compact. So we're going to continue our conversation about snowflakes and other weather patterns. But I want to hear from the groups. Was anyone able to effectively predict some of the elements that impact snowflake formation? Let's hear from you guys. What things were you able to make educated guesses about that were true?
We talked about humidity
Mm-hmm.
and temperature. One thing we didn't pick up on was the amount of snowfall and how that's a factor as well.
Absolutely. Yeah, you guys got a lot of the elements. I think you guys had similar ones as well, right?
Yep, so we got both the temperature and humidity, but we didn't get the
Awesome. And table in the back?
Yeah, we hit some of them, and I think they talked about the changes when it was falling too, so that was something we talked about as well.
Awesome. Yeah. So so depending on the region of the world and the temperature and the amount of snowfall, all of these factors impact the actual shape. So similar to how you created your own designs and try to replicate it with your partners, it was pretty difficult to make exactly the same snowflake. So you've got some similarities in shape and similar patterns, but it's almost impossible to create two that were exactly the same. So if you we'll look back at the question that you first answered about the things that you knew about snowflakes and snowfall patterns. Hopefully you've got a few things to add to that list. And then moving forward, next week, we're gonna continue our conversations about weather and the impact that weather and climate has on us as humans, but also our environment. And next week, we'll be looking at Antarctica and exploring that geographical region and looking at icebergs and the effect that icebergs have on our weather patterns. Awesome. Well, you guys have a fantastic day. If anyone doesn't want their snowflakes, I will take them and hang them up at my house. But if you do want them, then keep hold on to them and you can start to decorate for the holiday season.
So Jen, what did you like and what might you do different next time?
I really like crafts, and so I had a really hard time trying to figure out what to do for this particular lesson. So I was on Pinterest, and I came across the idea of like making snowflakes. So I tried to figure out a way to incorporate that into presentation. And so I liked the hands-on experience and like the analogy of how that connects to weather. Things I didn't like. I was a little bit worried about time that we wouldn't get through the activity, but I think it went fairly well. Some people were a little bit rushed. In the future, I'd have a couple more pairs of scissors and maybe not use the shaped ones because I know it makes it a little bit difficult to cut. But yeah.
Okay. So what observations do you guys have?
I think one thing about inductive and inquiry-based instruction is that you are inspiring all and you're wanting students to think about it and continue to like ponder it. And I feel like I really achieved that because I'm like still trying to figure out, even though there are like infinite numbers of ways that they can form, aren't there like infinite numbers of snowflakes that have fallen? And like, so there's this pondering and all that's going on that wants me to continue the learning process of that, and I think that's what inquiry instruction is all about, so I think we did that really well.
Awesome, great, thanks. It did get a little bit complicated, so when I was looking up, it's been a while since I've looked at like hydrogen molecules, and so I was like, I have to brush up my science a little bit. When I started looking up things, there is a huge controversy about whether or not some scientists think that there are, because there's patterns and things, that there are two that are actually like, so like I don't think we want to go into that like huge debate. And I forgot to mention it, but I did have a handout that explained things a little bit more as well. But I think what was challenging is like trying to figure out how to give enough information but not go too technical so that we still got through the activity.
So I would love to build on that. You did such a great job. I love this topic. I love your visuals. I thought your multimedia was appropriate. The only thing that you just mentioned would be the only slight thing that I would point out, and it's kind of like in a play. If you see a gun in the first act, someone needs to have that gun used in the play. Someone's going to get shot or whatever. And you had really great resources and handouts, and this was so awesome. It would be great to tighten it so that there's a direct connection between all of your pieces, and maybe all of your videos get a chance to see them. So I would just say that the most effective thing you did was the hardest part, which was integrate the activity in a way that connects it and it opens up thinking and all of that. Just to really, I just say it's sort of the other piece of it, the actual easier piece, to connect your handouts would be the only other thing, but I thought this was really so well done. Yeah.
Appreciate it.
So I thought you facilitated it very well. I thought you asked good questions to reinforce key areas. And so two minor things to think about. One is that I don't know that you quite made a connection at the beginning as to why it's important that we learn about snowflakes, particularly since we live in Florida, is to make that a little bit stronger. And then secondly, particularly if you're going to work with a younger age group of students, their abilities, their artistic abilities would be quite variable. We kind of joked it off a little bit, but if you had a young kid that couldn't do it very well, they might actually get shut down a little bit. My stepdaughter, she can't make something perfect. She like throws a hissy fit. And so it's just be ready that could happen with a younger group. But nice job.
Perfect. Yeah, if you don't want them, I will take them. If you want them, I will take them from you.
Okay, so we'll shift into our break and we will start back at 12:30.
You should survive.